Hello, grade fours, and welcome to another science lesson. Today we'll be looking at chapter number 6, lesson number 1 and number 2. This is just revision, and you will find these pages or these information in your books on page number 239 to 243 for lesson 1. So first of all, we're going to look at how you can classify minerals. So mineral crystals are small amounts of chemicals or elements found all around us. Mineral crystals, like table salt, are non-living. Each mineral has the same chemical composition. For example, if you find quartz in Asia, it will be the same as quartz in the Americas. So first of all, there are 6 ways to identify your minerals. The first one, we'll be looking at color, then luster, thirdly, hardness, then streak, fifthly, shape, and then the cleavage. We'll be looking at each single one of them individually and how you can identify minerals by looking at these ones. So first of all, although similar minerals have the same chemical compositions, they can have different colors. For example, these 2 minerals on the bottom is both quartz, but they have different colors. And this is because they were influenced by different chemicals that are around them. Secondly, luster. Luster is the property of how a mineral can reflect or absorb light. So first of all, we need to note that minerals can be classified in metallic and non-metallic minerals. So the first picture in metallic color is very shiny, so it does not absorb light as the second picture. It reflects light more than the second one. So then you get non-metallic minerals, like the vitreous is glassy. Then you get silky, which is a more fibrous type of mineral. Then you get resinous, which is plastic. Then you get waxy, which has a greasy or oily feel to it. Then you get pearly, which is very a silky type of feel to it, like a creamy type of feel to it. It looks very creamy. And then you get earthy, which is a rough, dull look like rocks. So if you look at crystals or minerals very closely, you will see the difference on their surfaces just by looking at their appearance. Thirdly, you can have hardness. So the hardness is how easily one surface of the mineral can be scratched. So if you look at the diamond is the hardest mineral that you get, but the softest one will be talc. Then you get the Mohs scale, which is there on the bottom, and the diamond you can see is number 10, which is the hardest, and talc will be the softest, where quartz will be at number 7 or fluorite at number 4. So each surface can be scratched easily by the mineral that is above it. So talc can be scratched by trapezium or calcite or fluorite much easier than it is talc can scratch the minerals above it. Fourth, we look at the streak. Streak is also the color that is left behind on a mineral when you scratch it on a special piece of paper. So some minerals leave a streak that others may not, and this depends on how hard a mineral is. And also the colors that are left behind may be different from the color that it is on the mineral itself. So this is the breaking down of the mineral, and then it leaves behind the color of the mineral. So if we look at the cinnabar, we know that a cinnabar can leave a brownish color behind while it is a gray color. Well, pyrite is a metal-looking mineral, and it leaves the same color behind than it is on the mineral itself. Number 5 is the shape of the crystal. The shape of the crystal can often be used to identify minerals. Each crystal solid shape, the flat surface, often the crystal can be square, rectangle, triangles, diamonds, or hexagons. So it depends on what the crystal is made up of and how you look at the crystal. So you can often see the crystal shapes when you either look at it under a microscope, or you can even see it like this. So the cleavage of the mineral will be the tendency of the mineral, how it breaks along the smooth parallel or parallel lines to the zone of weakness, which means if we look at the shape of this crystal, we can see that it is a cube-like structure, okay, and it will easily break along these lines that is easily seen when you look at the crystal. So that is the ways that you identify crystals. So now that we know how to identify crystals and minerals, we look at chapter number 6, lesson number 2. This is also a revision, so how rocks are classified. So classifying rocks. In this PowerPoint presentation, we'll be looking at the 3 types of rocks that there are: igneous rocks, sedimentary rock, and metamorphic rock. So we'll look at the Earth structures and what Earth structures look like, and how these 3 types of rocks are formed. So first of all, we look at the Earth's structure. So we get the crust, that is the very thin layer that we are standing on, that we can see the land masses and oceans that are on top of the crust. Then we get the mantle, which is made up of molten rock, and then the outer core, which is molten, but it is heavy metals that flow down from the mantle. And then you get the solid inner core, which is very, very, very hot. Now, if we look at the crust is between 0 to 100 kilometers thick, which in retrospect to the rest of the Earth is very small. If you would have shrunken down the Earth to the size of an apple, the crust would be roughly the size of the apple's outer skin, which is the peel of the apple. So then you look at the mantle, which is 2,900 kilometers thick, okay, or deep. So that is roughly 2,800 kilometers of mantle. Then it would be the solid or liquid core, which is next, and then the solid core. But this is molten, so the crust freely moves around on the surface. So the rock cycle. What happens to the rock cycle? First of all, you get magma from the molten crust and the mantle that is being pushed up. So the magma forms and makes these big chambers. And once there's enough pressure, it shoots out and forms igneous rocks. Igneous rocks then gets weathered and eroded and transported downhill into oceans and lower valleys. Now, these broken down igneous rocks are called sedimentation. So that forms sedimentary rock once there's enough of sediments that cool and dry. After the sedimentary rock, igneous and sedimentary rock, due to the heat and pressure from above and below, turns into metamorphic rock. Now, either the metamorphic rock can be pushed up slowly due to the tectonical plates that move around, or it melts down into magma, forming new molten rock, which can be made into igneous rocks again. So igneous rocks. Igneous rocks is one of the 3 main rock types. Igneous rocks is formed through the cooling and solidification of magma or lava. The magma can be derived from partial melts or existing rocks in either a planet's mantle or crust. So there are 2 types of igneous rocks. So these 2 igneous rocks, the one you can see cooled very quickly. This is magma that cooled very quickly, and this is over time the magma that cooled very slowly. Then you get sedimentary rock. Sedimentary rocks are types of rock that are formed by the accumulation or deposition of small particles and subsequent commendation of mineral or organic particles on the floor of an ocean or other bodies of water that are on Earth's surface. So there are 3 types of sedimentary rock that we can see there. So this is a small piece of rock that had small pieces of sediments that had fallen on top of one another over time, and this, due to weathering, broke loose and became a sedimentary rock. Now, sedimentary rock doesn't always look like this, so it can also look like the second picture where you can see the pieces of sediment inside of it. Thirdly, and lastly, you get metamorphic rock. So metamorphic rock arise from the transformation of existing rocks types in a process called metamorphism, which means changing in form. So the original rock is subjected to heat and pressure, causing profound physical or chemical changes. Now, you can see in the second picture where this graphite actually changed because it arranged the black pieces and the white pieces in a specific order. And this can only happen when there's a lot of pressure and heat. Thank you very much for joining me for the revision of these two lessons, and I hope that you understand the rock cycle and metamorphic, igneous, and sedimentary rock better, and also how to classify minerals.